Now let me recap the constant altitude cruising for jet aircraft. Okay, for endurance, okay, it will be this equation. So for you to fly at maximum endurance, you fly at maximum CL over CD. Okay, maximum CL over CD. So of course you want to have a big difference in carry as much fuel as possible, but that is limited to the design of the aircraft. Okay, and of course you must have a very economical engine where you have the lowest CT possible. But if you have this engine, okay, so that is a propulsion problem, and the weight is a design problem. So for given aircraft, you have to fly at maximum CL over CD. That is for jet aircraft. For the endurance, for the range, okay, like I said before, you have to fly at maximum CL to the power of half over CD. Okay, CL to the power of half over CD, and okay, fly as high as possible. So that's the reason why your jet aircraft, okay, your airliners flies at around 35,000 feet and above, cruising, and also to have the size of the wing small as possible. But again, the S or the wing area is the problem of design, because you have to consider the amount of weight that it must carry. So it must design the wing, and the wing also, aerodynamics of the aircraft must also have the highest possible CL to the power of half over CD. Okay, that is for jet aircraft. For propeller aircraft, okay, again, this is a constant altitude mode. If you look at the condition, okay, before and after, okay, it's the same, but the derivation of it will be different. Okay, the flow we're seeing, but we have engine power now. Now this engine power P is equal to the power available. Okay, the actual power that is delivered by the propeller and engine combination divided by the mechanical or fluid efficiency, the efficiency of the propeller and engine combined. So this is the actual power. So the actual power from the engine must be higher than the power available, because we have to also consider the inefficiency of it, okay, especially the propeller. Okay, now the change of weight over change of time is the power specific fuel consumption, okay, negative CP times PA over efficiency, okay, and if you rearrange, it will become something like this, okay. Okay, then the process is the same like the jet engine. Okay, so U integration of time from T0 to T1 will become endurance, and this integration of this, now we know that the power available, okay, for constant altitude cruise will be equal to the power required. Okay, the power required, okay, so meaning that we set the throttle, okay, the power to be the same as the required power, so that you can have a constant uh, constant speed cruising, okay, to match the cruise speed, okay, which is equal to drag times velocity, and also we know that lift is equal to weight. Okay, so replace that into where? Into this, okay, uh, this the PA part. Okay, this is not A, this is the PA. Okay, kena buat pembetulan lain sekali. Okay. Now, PA. Alright, okay, so PA. So gantikan, dapat this equation. Okay, L over drag kali velocity. This is actually your PA. Okay, 1 over PA. So and of course termasuk sekali W ni, sebab this is equal to weight kan, so sama. So you get this equation. So we know that weight, okay, since the weight is a function of velocity also, and velocity is not constant. Okay, it's not constant, so you replace this, okay, weight with this half rho v squared SCL, where your v is equal to this, okay, v is equal to this. Again, I made a mistake, okay, typo lagi sekali, letak lagi half kat sini, kena ada dua, okay, ada, Okay, and then put it into this equation. So endurance is equal to this, and after the ranking process, you get this. Okay, so this is for propeller aircraft. Okay, so propeller aircraft. So to fly at long endurance, for propeller aircraft, you must fly at maximum CL to the power of 1.5 over CD. Okay, again, this is another aerodynamic efficiency parameter. Okay, so you have to fly at this, number one, to gain the most endurance, fly the longest time. Number two is to have this as high as possible efficiency of the propeller. Okay, so it's good to have the variable pitch propeller so that you can adjust the propeller pitch to give you the most efficient. Okay, and of course the engine also mechanically must also be very efficient. Number three, of course, the fuel consumption, the CP, must be as low as possible. You must have a good engine that can sip fuel rather than gulping fuel. So the engine yang bagus. Okay. And other than that, okay, you have to fly at the lowest altitude possible. See, the roll is must be as big as possible. So the best is to fly at sea level, okay, near sea level, and you must have the biggest wing possible. Okay, so the biggest wing. This is if you want to have long endurance. So aircraft macam maritime patrol yang kena mengawal atau kena meronda di kawasan lautan yang luas pada keadaan pada long hours, usually have big wings and fly low at low altitude. Okay, and we also have features by the propulsion system that give you the best fuel consumption and also the best efficiency, propeller efficiency. Okay, and also fly slow because at maximum CL 1.5 over CD, okay, you fly at higher angle of attack than the maximum L over D. Okay, paham? Okay, now let's look at the range dia pula. Yeah. For range, again, kita keluarkan equation ni. Ds is equal to VDT, okay, and we recall that dW over dt is equal to this. So the same way we put for jet engine, we also put the same equation here. But not trust available lah. This time is power available. You have all those efficiency equation and CP inside. Okay. Again, you replace dengan equation yang sepatutnya. Okay. You know that PA is equal to like this. Okay. This equation, put it there. Okay. Now ini akan jadi range. Okay. Range, and now become this equation. Now it looks a lot simpler kan, lagi mudah. Okay, so as you do integration, okay, so kita dapat this equation. So if you look at this, in this case ini constant, ini ya sifat terbang and the weight. Okay, so and jadi ini. Okay, jadi ini. So this equation. Now for propeller aircraft to fly at maximum range, you must fly at maximum lift to drag ratio. Okay, and the rest is about propulsion system lah. Okay, propeller efficiency, maximum, minimum fuel consumption, power fuel consumption, specific fuel consumption. Okay, yang ni tertakluk kepada fuel yang dia boleh bawa lah. So lagi besar fuel dia bawa, lagi besar lah beza antara W0 dan W1. Okay, lagi besar beza. So nampak. So kapal terbang kalau dia sama, kalau dia pakai lain engine, dia perlukan different requirement. Okay, for it to fly the longest endurance. Okay, kata lain masa yang paling lama dia terbang, and also the longest range. But dua-duanya antara jet, okay, between jet and propeller, they have one similarity. If you want to fly longer range, in terms of range, you have to fly faster. Then, if you want to fly at the longest endurance or the most amount of time on air, so you have to fly slower. Okay, So going back for jet aircraft, maximum endurance, fly at maximum CLOCD. Okay. For propeller aircraft, for maximum endurance, fly at maximum CL 1.5 over CD. Okay. For longest range, jet aircraft fly at CL to the power and half over CD, whereas for maximum range for propeller aircraft fly at maximum CL over CD. Okay. So jet dengan propeller ada different requirement. Okay, different requirement for it to go farther or longer time. Okay. So when you design an aircraft later, nanti you akan consider this. Okay, apa jenis propulsion yang dia pakai, jet or propeller. Now how about EDF, electric ducted fan, electric vehicle? Yang mana satu dia nak pakai? Dia nak ikut propeller aircraft ke nak pakai ikut jet? Jawapan yang obvious ialah electric motor dia rate pakai apa? Kilowatt or horsepower. Dia pakai power. Walaupun dia pakai ducted fan yang nampak macam jet, tapi dia tetap propeller. So in other words, dia akan follow propeller. So apa bezanya jet dengan propeller? Bukan jet engine tu dalam ada kompresor juga macam propeller juga kan? Kalau turbo fan pun dia ada fan dekat dalam. So beza sangat. Ada lain sebab apa? Jet aircraft dia lagi complicated sebab dia ada thermodynamic punya hukum kat dalam tu. Jadi kat situ dia ada macam-macam kira angin dia keluar, ada heat yang masuk. Okay, ada heat yang masuk dan keluar. Okay, ada menghasilkan, akhirnya menghasilkan work. So that's a different story lah. Okay, that's for propulsion for you to study. Okay, later you study propulsion, you akan tengok benda tu. Okay, so itu beza dia. So for electric vehicle, dia follow macam mana propeller aircraft. Okay, sebab apa? Electric power dia pakai power lah, obviously power kan. So dia nak pergi maximum range, we fly at maximum lift to drag ratio. Okay, tak macam jet. Okay, ini kerja saya nak bagi assignment. Okay, you derive range and endurance equation. Okay, for both jet dengan propeller driven aircraft, maknanya ada 4 equation kena derive for constant airspeed mode. Okay, bukan constant altitude, constant airspeed mode. Ini tak ada dalam textbook. Derive. Boleh? Jangan marah. Minggu ni itu je. Okay? Alright. Selamat berpuasa, selamat beribadat. Okay? Jangan punting puasa. Okay lah. Saya pun nak pergi minum air sikit lah. Tekak dah kering. So nanti hari Khamis masa tutorial PBL punya session, kalau nak tanya, tanya. Okay, by the way, untuk assignment yang ini nanti saya announce lagi sekali, okay, dalam Google Classroom. Kali ni saya nak bagi markah lah sebab kerjanya bukannya senang. Saya bagi 6%. Okay, sebab you punya project mini project tu ada 6% markah yang datang daripada teamwork atau satu lagi presentation. So saya nak bagi free markah ni. You derive ni, upload dekat Google Form yang saya bagi dalam Google Classroom tu, and kalau betul semua, you dapat 6%. Okay. Kalau salah pun nanti saya komen, saya suruh you betul kan, you upload balik yang betul. So that's 6% for you. Macam boleh? Alright. Terima kasih banyak-banyak. Assalamualaikum.